according to your progression sheets, you guys know how to switch things between equal and congruent. You guys know what to look for as far as vertical angles, and you know what to look for what we call a reflexive side, something that's shared. So today we're going to add, I think, about 3 or so to these things. For example, if you are given a midpoint, like I was saying, this is kind of mixed between a whole bunch of different sections in chapter 2, 2, 6, 7, 4, 5. It's all kind of blended together. There's no one specific spot versus the other, so you don't worry about it. But think about this. What does midpoint do? Yeah. So when you have a midpoint, if you're given a midpoint, you know that you can say something. You can state segment congruent to a segment. Or you could say segment equals a segment. Either way, that's correct. Okay. Now, when we're dealing with these progression stuff, a lot of times what I do is I say, hey, if you're given certain bits of information, use it. Well, how do you use it? You state something out of it. Most things that go in the progression sheet are definitions, theorems, things like that. So, for example, if I draw a little picture in like a little statement reason, a little proof spot here, if I draw an example, and I say B is the midpoint of XY. If you think about the idea then, if you're given a midpoint, what can you say? Well, I know that a midpoint creates 2 congruent or 2 equal segments. So if I'm given this information, what would I say? XB equals BY. Perfect. If that's given, then you can say XB equals BY, definition of a midpoint. It's that quick little of a step to work with these. You're using the definition of a midpoint to say that those 2 segments are equal. Could you write congruent if you wanted? Yeah, either one is fine. You can say they're equal or you can say they're congruent. It doesn't matter which one you use. As we get into today's stuff, you'll see why one reason you'll write it congruent and sometimes you'll write it equals. It depends on the problem. Okay? Because when we did all of our adding, subtracting, multiplying, dividing with the equation stuff, that was always with equal. So today, a lot of the stuff that we do with segment addition and stuff, it's always dealt with an equal, so we'll keep it an equal. But as we get into triangles later, we just start talking about congruency. So you'll see a real subtle switch as we go through it. Excuse me. Not bad. It's just getting this information out in front of you so you don't lose any of this. You can use it. All right, let's do a different one. If given a segment bisector. Say you're given a segment bisector. What does a segment bisector do? Don't say bisect the segment. Can't bisect one, can you? You don't know where the middle is, do you? Yes, sir. It halves them. Okay. So if you're having something, what would you say in terms of segments? You get 2 equal segment segments, right? So you would state kind of the same thing, isn't it, as a midpoint? Yes. The only reason why I'm saying that we were going to put in this thing about segment bisector is that sometimes they'll use segment bisector instead of a midpoint. Okay. Remember, a segment bisector can be anything that bisects a segment. Midpoints are obviously just a point, but a segment bisector could look like this. what is XB according to that diagram? What is that thing called? Array. Yeah, it's a array. Okay. So array can bisect a segment. Another segment could bisect a segment. A line could go through something, through a segment and bisect it. But here I can say XB is a, I might as well just put right in the proof here. Is a segment bisector of AC. If that's given, what two segments are now equal or congruent? A, B, and B, C. You're using the definition of something you know. Mark a diagram and then state it. Well, AB equals BC. What do you think the reason is? Take a guess. Yeah, it's that literal. Definition, segment bisector. Oops. When you do proofs, they are very, very literal. They have to be done in a certain sequence to make things work. If you're given something that has a definition, use the definition. And by putting this on paper in these progression sheets, it's always going to be able, you'll always be able to go back and reference it to make sure that you're doing it correctly. Okay, so you can't stare at a proof and go, I don't know what to do. It tells you what to do. Okay? It tells you exactly what to do. Man? Speaking of segments and things, I know we've done examples of some other stuff. Excuse me. We've done some examples as far as what to look for and when. Well, one of the things I want you guys to remember is what does segment, let's do this. A little asterisk. What does segment addition look like? Because as of right now, we only know how to do a few things. Segment addition is one. Segment addition is one of those things that we know how to do. What does segment addition look like? Well, segment addition, when you have segment addition, we've done this before. The points all have to be where? They'll have to be on the same line. Collinear. Okay? So when you wrote up segment addition in the past, what would you say here? What would you do? It's just a reminder of what something looks like. Would anything change if I put another point here? What would I put? What would I have to? I would just have to add in some other letters and stuff, right? As long as they're all on the same line, it's not a big deal, is it? No, I'm not worrying about it right now. But I'm just saying, you can have more than 3 points in one. You can have 5, whatever. Okay, and it all works itself through. Let's see what's here. Ooh, I know another one. One that shows up a lot this week, especially because since we don't know a lot of proof stuff yet, we're doing a lot of algebra. So one of the things that shows up is well, let me ask you this before I go in there. What's 3 plus 3 plus 3 plus 3? 12, okay? What is 2 plus 2 plus 2 plus 2 plus 2? 10, okay? All right. What's 7, 7, 7, 7, 7? 35. So what you're doing is you're adding things over and over again. When you add the same thing over and over again, it's repeated addition, isn't it? What is that called? Multiplication is repeated addition. How about this one? Pete and repeat were in a boat. Pete fell out. Who was left? Pete and repeat were in a boat. Pete fell out. Who was left? Pete and repeat were in a boat. Pete fell out. Who was left? Pete and repeat were in a boat. Pete fell out. Who was left?
Annoying more. Oh my god.
Sorry, I had to. It's like how many lefts make a right?
3.
That was awesome. All right. I would. Nope. Reason why I was saying this one here is with a lot of the proofs that we're going to do over the course of the next few days, actually all this week, because I'm looking of doing this stuff all through Thursday, and we'll have a quiz on it on Friday. Because then next week we can start trying. Okay. It's not as bad as what it's what people always say. It's you only know certain things, and the things that we know today: segment addition, midpoints, multiplication is repeated addition. There's only substitution. There's only a few things you know. So what I wanted to do here was to show you guys that multiplication is repeated addition. For example, if I write 2xy, that's 2 times xy, right? If I wanted to write that in terms of addition, what would it look like? So if I had to do this in a proof, I could state that 2 times xy is xy plus xy. Because the reason is definition of multiplication. Okay? And it works the exact same way going the other direction. It works the exact same way going the other direction. If I did WZ plus WZ plus WZ, what would that have to equal? 3 times WZ, yeah. Again, it's something that shows up pretty regularly these first few days. We have plenty of squares. Might as well put one in there. That way when you come across it, you're not going to go and freak out. At least we hope. Okay, at least we hope. Okay. You okay? All right. So let's try one. Let's do a proof. Given segment AD is made up of 2 times segment AB plus BC. All right. When you have your given, we have a given and we have a proof and a diagram. So take a second, draw it up, and we'll go through a pretty decent little proof here. It's whenever you're doing proofs and you're writing things out and you're drawing diagrams, always take note of what information they're giving you and take note of what you have to prove. So you're looking at, you've got a segment that they're giving you that's made up of other segments. But then they're trying to prove that something is congruent. Notice how the first thing is math. 2 things add up to equal something else. But at the end, there's congruency. That tells you right there you had to switch from equal to congruent. Okay? you see that in a proof, you know that you had to switch it. Same thing goes for if it starts with congruent and it ends in equal, that means you had to switch it somewhere along the way. All the math that we do, the properties, adding, subtracting, multiplying, dividing, those are always done with equals. You can say something is congruent as you get into it. Okay, that's where that comes from. Just a little heads up when you start seeing it. So as I'm going into this, I'm looking at info. AD is made up of twice AB plus BC. That's given. Now when I look at my diagram, AD is that entire segment in it.
Yes.
Okay. Now if I look at that diagram, that whole segment of AD is also made up of what segments? You list them through. AB, BC, and CD. If I add all three of those together, I'll get AD, won't I?
Yes.
Okay. So we write it down. AD is AB, BC, and CD. What did you just do?
Segment addition.
Perfect. You added a bunch of segments together to make a bigger one. You used segment addition. Okay. Again, you have that on that progression sheet. You have an example of what that looks like. You know if you're adding two segments together and you get another segment, probably segment addition. Aren't those the same?
Yeah.
They equal different things now?
Yeah.
They do, don't they? See how it equals twice AB plus BC, and it also equals AB, BC, and CD? Exactly, because of what? No. Putting something in for something else.
Oh, substitution.
Substitution. When two things equal different things, those other things are equal. It's a weird way of saying that. Substitution. Just a reminder. I know you have this written down. I think it's on your reason bank. When two things are equal, and sorry, two things that equal the same thing are equal to each other. Two things that are equal to the same thing are equal to each other. Both of those two segments add up to equal AD. That means those two segments have to equal each other. Okay. Now you're basically at an algebra problem. When you start looking at it, it's an algebra problem without any numbers. It's just got a bunch of letters. This will be the exact same stuff as we get into with angles, but angles will have more letters because angles usually use 3 letters and a symbol. Okay, so this is where your handwriting has to get a little bit cleaner. Which means my handwriting needs to get a little bit cleaner. Well, you'd have to agree with me that fast. Excuse me. So if I'm looking at that algebraic statement there, or that equation, is there the same thing on both sides somewhere? What? Well, right now I'm just looking at the BCs, okay? Because there's two ABs, I have to split that into two separate ones. But here I've got a BC on both sides, don't I? How do I get rid of them? Okay? So you did this last week with the algebra stuff. When minus prop equal. When you're doing subtraction, like you did on all of your equations, you did the algebra, but you wrote down the reasons of what you did. What property did you use? Well, minus prop equal. When you rewrote something, what did you do? What was it? Simplify. Now we have 2AB is AB, and CD. Okay. Multiplication is what? It's repeated addition, right? Okay. So what could I rewrite that 2AB as? Okay. This one right in front of you. What's that? Yep. Yep. Guys, when you rewrite it, it's just definition of multiplication. That's why we put that in a square a minute ago. When you rewrite something from the 2AB or 2XY or 7AB or whatever, when you go from multiplication just showing that it's repeated addition, that's literally the definition of multiplication. That's why we put it in that square. Okay? It's not multiplication property of equality. You're not multiplying the same thing anywhere. You just rewrote it. Okay? Now, some people have asked, why can't you just subtract AB over? Unfortunately, with proofs, you have to be extraordinarily literal. If this was like 2x equals x plus 4, you would have just subtracted x because you pick on the little guy and so on and so on. With these things, you have to split that up. That's just how they do it. It's one of those weird rules. Okay? It's just a step. Now do you have the same thing on both sides again? What are you going to subtract? Yep. When you rewrite, you are simplifying because there's no solve here. I'm not saying that AB is 4. You know what I mean? I'm just saying that AB equals CD because I simplified it. But what did it want us to show? That it was congruent. So now what's the last thing I do? Not solve. Remember, not saying not simplify. Definition of congruent. Because when you switch from equal to congruent, you're using that definition of congruent. That should be on your progression sheet. All right? And that's the idea. You always reference back and forth to what you're trying to show to start with. I'm not going to yell at you if you don't put the lines on top. I think it's too messy. Okay? But that's quite literally how we do this stuff. None of this was any difficult than anything we've done before. All of these properties of things, substitution, subtraction, you did all of that last week. The only thing that's kind of new is that we're using that definition of multiplication. And the only other thing that's different in here is that switch at the end. This is just an algebra problem with no numbers. Okay? It's just an algebra problem without any numbers. Not terrible. Okay. All right, let's do this one. Let's go to this one. We'll go to a midpoint. We'll go back to the other one in a second. So if I start this one out, it says that B is the midpoint of AC. And then it wants us to prove that AB plus C is B. It is. Proofs are a lot of right. I mean, think, and honestly, I was kind of looking at calendars and stuff. My best guess, we'll probably be done with proofs right about Thanksgiving. But it's, no, but if you think about it, that's really only like 5 weeks out.
What do you mean 5 weeks? Yeah, 5 weeks till Thanksgiving.
Sounds about right.
Until Thanksgiving, not
But it's not that far out, really isn't. But the idea with the segment or with the proof stuff is that this easy stuff is where we start. Next week we get into triangles. That takes a little getting used to. But again, you've got these sheets in front of you, these properties and stuff. They never change. It's just a matter of what information do you have, what can you show, and that's where this stuff comes from. So as we go into this, before we start writing everything out, like I've been saying, I always like to start with reading my given, go to my diagram, and mark anything that I can. So if I have B is the midpoint of AC, that tells me what can I do to my diagram. Tick mark what? I know that these two have to be equal to each other because that's what the midpoint says. Okay. Now, that's the only given statement that we have. So now I'm going to look at what does it want me to prove. It wants me to prove that BD, this segment, is made up of, what was it, AB and CD. But AB isn't part of it, is it? But what is? BC is. And aren't AB and BC the same thing? So if two things are the same thing, what can you do with each other? You can do some substitution. So you start to see what you're going to be working with, okay, before you start writing it all out. So now you start writing it out. B is a midpoint of AC. Get it? According to our progression sheet, when I have a midpoint, what's the very next thing I'm going to state? You're doing segment addition. I'm talking about the midpoint. What am I going to do with the midpoint? Yeah, segments are congruent, segments are equal. Do I want to use congruent or equal with this one, do you think? I want to use equal. Why do I want to use equal? Because there's equal here, okay? If you used congruent before you did any math with it, you have to switch it. Is it wrong to do that? It's just adding steps, okay? So that's why you're allowed just to use either one. So I would go ahead and do AB equals BC. Definition of a midpoint. Okay. Now, like we did a minute ago, we looked ahead a little bit into seeing what is it that you had to show. Well, we have to talk about segment BD somewhere. We know that segment BD is made up of what two smaller segments? Okay, so let's write that down. BC plus CD equals BD. When you add two segments together to get a different one, what are you using? Segment addition. Okay. So what can you do? Yep. Since BC and AB are the same thing, we've already said that. Anytime I write BC, I can replace it with AB. I can put something in for something else. When two things equal. Substitution. Have you proved what they wanted you to prove? Yes. It's quite literally that straightforward. You use the definition that they give you. You might have to come up with one extra step on your own, which all we had to do was come up with that segment addition part, and everything else falls into place. So if you go back and you think about, in this proof, there were 8 things that we had to write down. Of those 8 things, you only had to come up with 2 of them, because you had to figure out how do you get that segment addition part in there. That's 1/4 of the thing. 75% of that proof is already done. Yes, ma'am.
Okay, I'm a little confused because you went from BC to AB.
Are AB and BC the same? According to that proof?
Oh, okay.
And that's why we can do that. So anytime that you have 2 things that are equal to the same thing, they're equal to each other. In this case, it's just, you can also say that you can put something in for something else. So you can put something in for something else when they're equal to each other. Okay, that's the idea. All right. Again, 75% of that proof was done. You just had to figure out that last little bit. And that happens a lot of times with proofs by going through the progressions. And if you have no flipping clue on what you're doing, if you just have this in front of you and you list out going from your given statements, you're eventually going to get over half of everything. It's kind of foolproof. I wouldn't go that far, but it helps out. It helps out a lot. Okay. So back to this guy. No, we'll do this one together again. I don't want you guys going on your own yet. Even today, I have 4 proofs for you guys to do. 3 of them are fill in the blank. 1 of them is on your own. It's baby steps, guys. It's baby steps here. All right. Yeah, that's a good one. Now, I want to explain to you the wording in this. It says B is between A and D, C is between A and D. Does it say that? They're just in between. If they're both in between, that just means they're all on the same what? They're on the same line. Basically, this is allowing you to say that they're collinear, which basically, if things are collinear, that means you can use segment addition. This is just telling us that all 4 of these points are on the same line, and that B and C are between the endpoints. Okay, when you're looking at it, kind of. We'll get there. All right. Give you a second to draw this up, and I'll explain to you how do you kind of look through it to try to see where you're going to go to. Unfortunately, these parts here, when they're talking about, how I've been saying with progression stuff, if you're given something, use the definition and all that. These guys, there's no progression. All it's saying is like, hey, they're in between. So you just write it down. Okay.
I have a question.
Yes, ma'am.
Can you write like B and C is between A and B?
No, because they're 2 separate steps.
Okay.
Yeah, that's a good question. I would always, when we're doing all of our given statements, I always write every single one of them out separately. Plus, each given statement might have something that you can say about it. For example, if you were given 2 different midpoints and you had an angle bisector, that's 3 given statements that all 3 of them have something you can say with. So I would split up my givens and say something specific about each one of them. Here, I would just write them both down and write given next to each one. There's nothing I can do. It'll show up more when we get to triangles. Yeah. Yep. Always put them on separate lines. Okay. That way it keeps everything straight. So when we're looking at this, now I want to take a second and look at what they want us to show. They want us to say something about AB and BD has to equal AC and CD. What's another name for AB plus BD? AD. What's another name for AC plus CD? AD. What are you doing right there? Before you get there, segment addition. You're doing segment addition. By looking at the diagram about what they're trying to get you to show, I can say that AD is AC plus CD. I can say AD is AB plus CD. That's what I'm getting at, because then I got 2 things that are equal to the same thing, right there, which therefore means that they are equal to each other. That's the idea. You look ahead where you have to go. I know that AB plus BD is AD because I'm adding segments. And I know that AC and CD. I know that has to happen. Because they're all in the same line. Segment addition says I have to add two smaller segments together, it equals a larger. And now I just use what? Substitution. And I'm done. Get substitution out of that. Okay. Again, it's hopefully not scary. It's only thing you guys know, segment addition, midpoints in segment bisectors. That's it. Everything else is algebra. That's how we're doing this with segment additions. Subtractions, multiplication, things like that. Okay. It's utilizing stuff that's in front of you to get to the next step. We got time to do one more. Oops. Here's an example of two midpoints, which means when I write them out, I'm going to write them out separately. Okay. You're given that M is a midpoint of AB, and you're given that B is a midpoint of MD. So before we start drawing up the two columns and whatnot, I don't want to get too far ahead of you here. Start drawing this out. Before we get going in there, after you write out the two givens and what you're supposed to prove, take a second and look at the diagram. What can you mark up on your diagram? Tick marks, yeah. I know that if M is the midpoint of AB, what two segments have to be equal? AM and MB. Okay. If this is the midpoint of, if M's the midpoint of AB, those two have to be the same. And if I look at the next one, it says that B is the midpoint of MD. MB and BB have to be the same. But since MB has one tick mark, how many does the next one get? Ah, they're equal, aren't they? Should also have one. Yeah. Okay. And what you're saying is like they're all equal because if I'm taller than you, you're taller than her, I'm taller than her, you're kind of using that transitive by going through all that. We don't have to show all that, but you're right in saying that. Right? So you go through your givens. M is midpoint of AB. That's the definition that we have a progression for. So we go to our sheet and we look, all right, where's midpoint, where's midpoint? Oh, there's midpoint. If given a midpoint state, segment equals segment. Okay. What were the two segments that are equal here? We already marked it. Just gotta write it down. The other given. This is why, and guys, this is another, like we were talking earlier, you were asked about when we list all the givens through. Anytime you have a given statement that you can do something from, you always do it. Because a lot of times what will happen is that if you've got two givens or three givens, you might forget to do something about one of them. This just tells you if you're given this, state this right away. Always do the statements right off the bat. Then you go to your next one. And then according to our diagram, we already marked those. That means that what MB and BD are equal. What do you think?
I want to say no.
Okay. Before we run out too much time here, look what you have to prove. You got to prove something about MD. According to your picture, what is MD made up of? So what can you say? What do you say? And what do you do? No, what is that? Segment addition. Now, I know I'm running out of time, but if you look at it, what do you know about MD and BD? They're equal. So I can, since I got to talk about two MDs, what do I do here? Substitution. You have substitution, and then what's your last step? Not solve. Not simplify. When you're going from repeated addition to multiplication, you're doing what? That's why we showed that.
Wait, what would it be?
Definition of multiplication. Now these aren't numbered. And I'll show you which one I want you guys to do. On the first page, proof at the bottom. You gotta get this down. Second page, proof at the bottom. And then on the third, the top and middle. Okay, there are 4 of them. Of those 4, 3 of them are fill in the blank.
What about the fourth?
Again, we're only talking about segments, not worried about annuals yet. We haven't gotten there. Okay? So the first page is proof at the bottom. Second page is proof at the bottom. And the third page, there's 2 proofs, the top and the middle. Those are all segments. This should be extraordinarily straightforward. 3 of them are fill in the blank, figure out what properties are going where, what reasons. The last one is on your own. You should be just fine. Have a good day.